Alright, let's continue this tutorial. As I showed you earlier, I'm gonna code the circuit we saw. So, we use asterisk to make a comment. Just put the asterisk at the beginning of the line. Don't put it in the middle, it won't work. And generally speaking, don't play with JSIM a lot because it creates lots of mistakes. So you just need the notepad. A txt file will do. And let's get started. So I'm using the asterisk here to define the two junctions B1 and B2. B is the letter used to define a junction, a Josephson junction, and the node it's the node 2 and node 0. 0 is the ground, and I named this JJ hype from Hypers. This is not really given word. You can write whatever you want because you may have a lot of junctions in the same circuit that they're different. They have different characteristics, like different areas, for example, or critical currents. So we have two, they're identical, so I'm using the same name. Then I define the external shunt resistors R1 and R2. R is a given letter for resistor, node 2 and node 0, and the it's 1 ohm. If you write nothing, it assumes it's the original value. Then I'm defining the four inductors. You only need L, L1, L2, L3, L4, L5. It's 1 and 2, so node 1 and node 2. 2P, P is for pico under is in our occasion. And then I'm using the given word F check, which means flux check. It keeps track of the phase in the inductor, change of phase in the inductor. If you don't do it, it won't record the phase, and you might need it afterwards. So just stay in the habit and always put F check. It's not a big deal. Then I'm defining the load resistor. As I said, R is the given letter. R load, node 5 goes to the ground, and it's 2 ohms. Then I'm defining the bias. The I is the given letter for bias. I bias is 0. One node is to the ground, the other one is to node 3. PWL is a function that creates a waveform. So in the parentheses we use 0. 0 first goes the time and then the amplitude, so it's 0 seconds, 0 amps, 5 picoseconds. If you don't put the P, it will assume 5 seconds, 350 micro. It knows it's amps, so you don't have to put amps, so U will do for micro. Then I'm defining the input as well. The input, V is a given word for voltage, node 1, node 0, and then PWL. 0, the first two elements I forgot to mention have to be 0. Do not attempt to put anything else. It's gonna give you, it's gonna crash, and make sure you don't forget the P's or nanos or whatever you want to use. 0 seconds 0 volts, 50 picoseconds 0 volts, 52 picoseconds 830 microvolts, 55 picoseconds 0, and then I'm doing the same thing again but at 100. So that was gonna create two spikes, two flux pulses as input, and for example, if I don't use that that 50 picosecond and 0 here is gonna create more like a step one, so you pretty much connects the points, and yeah, you need to make sure you're doing it properly as well. As I said earlier, we can have many junctions, so you need to define your model, and dot model will do the definition, and then JJ hype is the name I gave to my junctions above, and then you use this function JJ, and you put a whole lot of parameters in here. So one is the R type is 1, Rn is 7.7, I critical 250 microamps, capacity is 330 F for femto. Use this one for the RSFQ and the niobium tri-layer process. It's pretty much very close to Hypers. I'll try and experiment a bit more next time, and maybe we can add some extra parameters. That will definitely do the job for now. Then you have to calculate the transit response. So dot tran, do not type dot trans, because you're gonna waste 1 hour trying to find what's wrong. 4 arguments. Where does it start? Where does it stop? What's the step and the time step in between? You don't need all of those. I guess you could do it with 3 arguments, but if you want a very high resolution, you play with those. And if it's, for example, 1 minute, then you have to set that to, I don't know, do the calculations like 60 seconds. 60 seconds will give you an enormous amount of data. Then if you're using Windows, which is what I'm been doing, you have to use .file out.dat. That will create a file with lots of numbers inside it, so arrays of numbers, and that's where you are storing all your information. Then I'm gonna use MATLAB to plot it. .print device v in. So what does that do? Is printing the device v, so the voltage of a device, v in, so that's our input. So we should have 2 spikes here, and then I want to print the voltage at the output, so dev vr load. You can print the voltage in a node if you want. It does all the calculations for you. And then in this occasion I'm printing the phase of B2. B is a given letter, as we said earlier, for a junction, and dot print div I, that will give us the device I, the current of the device, R load. Just for a demonstration, don't really need it in this example. So once you do that, you have to save it, close the file, and make sure you rename the file to the extension, not the file, to .cir. So in my case here, if I do anyway, if I do .cir, it's not gonna work, because I'm not changing the extension, I'm changing the name. So in this case, I've changed only the name, but it's still a txt file. You need to make sure it's a CIR file. So you know how to do that, I guess. So once you've done that, you're ready to run your program, and hopefully it will work. Thanks a lot. We'll see you in the next tutorial.